This is the factory site and headquarters of Newage Stamford in Lincolnshire, England, Europe's largest manufacturers of alternating current generators in the range up to 750 kVA. A company which exports sources of prime and standby power to some 70 countries. The growth of the company and its success has been exceptional. This is what it looked like in 1960. Within 5 years, the size of the plant had doubled. It doubled again until the present 12.5-acre site today has 4 times the original work area with a 10 times production growth rate. The reason for the company's success is based mainly on 2 things: quality and reliability through innovation of design, and a concentration on just one product, AC generators. Our story is concerned with the manufacture of the generator frame C434 and a contract involving 80 to be supplied through Newage Stamford's German subsidiary company, Newage GmbH, and thence to Beckman KG, both of whom based in Hamburg, with Beckman building them into generating sets complete with their engines for the Iraq Air Force. This cutaway model shows the brushless generator, which greatly reduced the number of separate components, wearing parts, and maintenance, as well as improving efficiency. It is the result of more than 25 years of Newage Stamford design and manufacturing experience. As a result, it is probably the most advanced technological product of its kind on the market today. A workforce of 700 people are employed to keep pace with the rising demand, and the highly specialized skills needed start here in the tool room where the jigs and fixtures are made. Skilled renovating of tooling for the lamination process is also carried out here to keep them up to date. The work in the machine shop starts with the vertical boring of the castings for the C434 generator frame. The next stage is to position the casting in a special jig for drilling. New methods are being introduced all the time, and this jig, with end plates located by clamps, enables all drilling operations to be completed. A main feature of the jig is its ability to rotate, so that all drilling operations on both ends of the frame can be carried out quickly and accurately. The foot mountings on the frames are milled and drilled on a tape-controlled machine. One man controls 2 sequence turret lathes, which machine the drive end brackets. This operation is carrying out the machining sequences on the spigot of the non-drive end bracket. Yet another sequence turret lathe is used for the fine machining operations on the bearing outer cap. The sequencing and positioning of each tool for the various operations is carried out entirely automatically. This is the end result, a precision-made product manufactured to fine tolerances. The shafts of the generators are produced on profile copy lathes with the tool following the precise profile of the model. Grinding of the shafts follows, and this is another highly skilled process as the final measurements must be precise. Now we come to the heart of the generator, the stamping of the laminations for the stators and rotors. New at Stamford are introducing new machines whenever necessary to improve and refine the various manufacturing processes. Important machines such as this and the manufacturing techniques involved have been designed for quantity production. The rotor laminations are assembled into their rotor packs. The same assembly routine is carried out for the stator packs. The built-up laminations are then welded together to form the complete rotor and stator core packs. The winding, which follows, is one of the few hand-controlled processes, as each rotor and stator needs skilled and individual attention. In the case of the stators, these are wound with Class B insulation materials using pre-formed coils. The wound stators are tested before moving on to the next process. This is impregnation by dipping in a tank of varnish and then drying in an oven. After this, they're sprayed with anti-tracking varnish. In the final assembly stages, the frame is lowered onto the wound stator. Meanwhile, the rotors are wound using Class F insulation materials. The rotors are then heated by passing direct current through the windings and then impregnated by trickle feeding an epoxy resin. Now the completed and fully treated rotor is ready for assembly onto the shaft. Balancing tests come next to ensure that they are within the tolerance limits required. The C434 generator was tested at the prototype stage when going through its initial research and testing program. This also included subjecting the Series 3 voltage control unit to vibration tests in 3 planes. As a result of this, a standard program for testing component batches was introduced to make sure all are working and up to the high standard of their specifications. The voltage control units are built up by hand. Soldering of the external wiring to the components is carried out before an automatic flow soldering technique is used for the base of the printed circuit. The voltage control units are finally tested on a slave generator. Then we're ready for the assembly of the main components. Production and quality control testing is done to British Ministry of Defence standards, with proving and testing of every single generator before dispatch. The generators are overloaded during this test deliberately to ensure that the voltage control units and other safety devices are functioning correctly. New-age STAMFORD generators sold to United Kingdom companies and subsequently exported as part of complete generating sets, and those generators exported direct, as with this particular contract for the government of Iraq, account for 85% of all the factory's production. New-age engineers from the UK are able to provide a continuing global service of personal advice and attention virtually anywhere, with the further backup facilities of subsidiary companies in Australia, Canada, France, Italy, Norway, Singapore, Spain, United States of America, and Western Germany, as well as 75 distributors throughout the world.